Hello friends, in this video we are going to discuss JEE Advanced 2014 Mathematics Paper 2. The first question it says the function y equals fx is the solution of the differential equation dy by dx plus xy upon x square minus 1 equals x raised to the power 4 plus 2x upon under root 1 minus x square. In minus 1 1 not included, satisfying f0 equals 0. Then integration from minus root 3 by 2 to 3 by 2 to root 3 by 2 fx dx is. Okay, so the given equation is dy by dx minus y into x upon 1 minus x square equals x raised to the power 4 plus 2x upon under root 1 minus x square. Okay, now let's take the integration factor, that is if, as e raised to the power minus integration of x upon 1 minus x square dx, which is equal to under root 1 minus x square. Okay, so from here, so therefore y under root 1 minus x square equals under root x raised to the power 4 plus 2x dx, which gets solved to x raised to the power 5 upon 5 plus x square plus c. Now since we are given that f0 equals 0, that is y at x equals 0 equals 0. Okay, so now if we put x0 here in this equation, then this gives us 0 equals c. Okay, or c equals 0, right? So therefore y equals x raised to the power 5 upon 5 plus x square upon under root 1 minus x square, which is nothing but fx. So now, therefore I is equal to I, which is asked here in this question, is minus under root 3 by 2 to under root 3 by 2 fx dx equals integration minus under root 3 by 2 to root 3 by 2 x raised to the power 5 upon 5 plus x squared upon under root 1 minus x square dx. Now since we can split it up, so let's split it up. This will be under root minus integration of from minus root 3 by 2 to root 3 by 2 x raised to the power 5 upon 5 under root 1 minus x square dx plus integration from minus root 3 by 2 to root 3 by 2 x square dx upon under root 1 minus x square. Okay, now since we know that this is an odd function here, this function is an odd function. This is an odd function because f minus x equals minus fx, and the limit is from minus a to a. Okay, so therefore this will correspond to 0 here, and this is an even function. Okay, so since we know that if fx is even, then integration from minus a to a fx dx equals 2 twice of integration from 0 to a fx dx, and this function here is an even function. Okay, so far after this we can say that I is equal to twice of integration from 0 to root 3 by 2 x square dx upon under root 1 minus x square. Now if we say that let x equals sine theta, if that is the case, then I equals twice from integration 0 to pi by 3, because at x equals root 3 by 2, theta will be pi by 3. It's not 2, it is pi by 3. Okay, so I will be equal to sine theta square d theta. So this will be integration from 0 to pi by 3, 1 minus cos 2 theta d theta. Okay, so this is nothing but this is theta minus sine 2 theta by 2 from 0 to pi by 3. So this is equal to pi by 3 minus root 3 upon 4. So this is the answer here. So the correct answer here in this case is option. Correct answer is option B. Okay, so the correct answer is option B. So let's see another question. The question says the following integral is this, integration from pi by 4 to pi by 2 cosec x raised to the power 17 dx is equal to. Okay, so if I is equal to integration from pi by 4 to pi by 2 cosec x raised to the power 17 dx. Now since we know that here negative of cot x equals 1 upon cosec x plus cot x. No, not negative of cot x here. You can write here negative of cot x plus cosec x. Okay. So cosec x minus cot x equals 1 upon cosec x plus cot x. So from here cosec x equals cot x plus 1 upon cosec x plus cot x. Okay, so I can write I in this another form. I equals integration from pi by 4 to pi by 2 into 2 cosec x raised to the power 16 into 2 cosec x dx. Okay, so it can be written as integration from pi by 4 to pi by 2. Since cosec x is this, cosec x plus cot x plus 1 upon cosec x plus cot x raised to the power 16 into 2 cosec x dx. Okay, this can easily be proved if we multiply and divide this expression by cosec x minus cot x. Okay, and then using the formula that cosec x minus cot x equal cosec x square minus cot x square equals 1. So from here I okay, so since I is this, now let cosec x plus cot x equals e raised to the power u. This is u. Okay, so from here this implies that minus cosec x dx equals du. Okay, so therefore I equals minus 2. If we substitute these values here, then I equals minus 2 integration from ln root 2 plus 1 to 0 e raised to the power u plus e raised to the power minus u raised to the power 16 du, which gets simplified as, if we interchange the limits here, this will be integration from 0 to ln root 2 plus 1, 2 into e raised to the power u plus e raised to the power minus u raised to the power 16 du. Okay, so this is the answer here. So the correct option here in this case is, the correct option is option A. Okay. Okay, so now let's move to another question. The question says coefficient of x raised to the power 11 in the expansion of 1 plus x square raised to the power 4 into 1 plus x cubed raised to the power 7 into 1 plus x raised to the power 4 raised to the power 12 is. Okay, so there can be 4 ways to achieve the coefficient of x raised to the power 11. Actually, in case if we just expand this expression, then x raised to the power 11 will be formed with the combination of 4 coefficients. Okay, so let's see how those coefficients are formed. Here there are 3 powers which we deal with here: the power of x square, the power of x cube, and the power of x raised to the power 4. Okay, only these powers are going to give us the coefficients of x raised to the power n, where n is a natural number. So if the power of x square is 0 here, in this case, if this is 0, if this is expanded for the first time, so if the power of x square is 0 and the power of x cube is 1, now the power of x raised to the power 4 should be 2, so that it is, in this case it is 4 into 2, that is 8. 8 plus 3 equals 11. Okay, so in this case the coefficient is going to be, since if this is power, now this is the first case, let's see the other case. In other case, this is x square is the power of x square is 2, the power of x cube is 1. So in this case the total becomes 4 plus 3 equals 7. So now the power of x raised to the power 4 has to be 1. That is, so that 7 plus 4 equals 11. Now the third case here is the power of x square is 4, the power of x cubed is again 1, and the power of x raised to the power 4 is 0. And the fourth is the power of x square is 1, the power of x cubed is 3, and the power of x cubed is 3, and the power of x raised to the power 4 is 0 again. Okay, so in all of these 4 cases, the coefficients are going to be different here. The coefficients, if we write coefficients here, okay, so if you write coefficients here, so in this case the coefficient is going to be, since this is 4, this is 7, this is 12, so we are going to deal with 4 along with x square, and with 7 along with x cube, and with 12 along with x raised to the power 4. So this becomes 4c0, the coefficient becomes 4c0. There are this many ways to achieve this this combination. This combination corresponds to 4c0 into 7c1 into 12c2. Okay, in this case it is 4c2 into 7c1 into 12c1. In this case it is 4c4 into 7c1 into 12c0, and finally in this case is 4c1 into 7c3 into 12c0. Okay, so this becomes here, this becomes here 1, 4c0 is 1 into 7c1 is 7 into, or if I write, suppose this case is 1, so in case of 1 it becomes, it is 4c0 into 7c1 into 12c2, so this is 4c0 equals 1, 7c1 equals 7, and 12c2 2 equals actually 12 into 11 by 2, which is 66. Okay, so this becomes 1 into 7 into 66, which is equal to, which is, if we calculate it, it becomes 462. In second case, this is 4C2 into 7C1 into 12C1. So this becomes 6 into 7 into 12, which is equal to 504. In the third case, it becomes 4C4, which is 1 into 7C1, which is 7 into 12C0, which is 1, equals 7. And the last case, that is the fourth case, it becomes 4C1, which is 4 into 7C3. 7C3 is 35 into 12C0, which is again 1, which becomes 140. Okay, so the correct answer here is, therefore coefficient of x raised to the power 11 equals the total of these. Okay, so this becomes 462 plus 504 plus 7 plus 140. So the correct answer is 1113. Okay, 462 plus 504 plus 7 plus 140. So the correct answer becomes 1113. So the correct option here is option C. Okay. Now let's see another question. The question says, let f from 02 to r be a function which is continuous on 02 and is differentiable on 02 not included with f0 equals 1. Let capital Fx equals integration from 0 to x square f root t dt. For x belonging to 02, if f dash x equals small f dash x, for all x belonging to 02, then f2 equals. Okay, here. So now since capital F x is here, the capital Fx is integration from 0 to x square f root t dt. Now we know an expression. We know that if capital F x equals integration from g1 x to g2 x small x dx, then the capital Fx by dx equals d by dx integration from g1 x to g2 x fx dx. So this becomes, this becomes f g2 x dash, which is dg2x by dx, minus f g1 x into g1 x dash. Okay, so therefore capital F dash x is equal to fx into 2x, which is equal to f dash x. Okay, so now since we are given here that because capital F dash x equals small f dash x, okay, it is given in the question. So therefore from here, this small f dash x upon small fx equals to 2x. Okay, so from using these two, this is equal to 2x. So from here we can say that fx, if we integrate it, then we will get fx equals e raised to the power x square plus c, or in other form we can write fx equals k into e raised to the power x square, where k is a constant. Okay, now since f0 equals to 1, therefore this implies that f0 equals k, and therefore k equals 1 here, because f0 equals 1. Okay. Okay, so now moving further, therefore capital Fx equals integration from 0 to x square e raised to the power x dx. Fine. So therefore this becomes equal to e raised to the power x square minus 1. Okay, so the correct e raised to the power x square minus 1, and hence therefore capital F2 equals e raised to the power 4 minus 1. This is the correct answer here. Okay, so the correct option here in this case is option B. Okay, so now let's move on to other question. The question says the common tangents to the circle x square plus y square equals to 2 and the parabola y square equals 8x touch the circle at the points PQ and the parabola at the points RS. Then the area of the quadrilateral PQRS is. Okay, so let's draw the diagram first. So if we draw the diagram, then the diagram will look something like this. Suppose this is the coordinate axis. Okay, this is the coordinate axis, and here we have this circle. Here we have this circle, right, like this. Okay, although my drawing is not perfect, but this is somewhat roughly the diagram will look like. Suppose this is the diagram, and the tangents are here like this. Okay, the tangents are like this. Suppose, so this is P, this is Q, this is R, and this is S. So they are asking us to calculate this area. Fine. So let's see what these points correspond to particularly. If we draw a straight line like this, then this particular quadrilateral PQRS will get splitted in the form of a rectangle. This is a rectangle and these are two triangles. Okay, so these are the two triangles. So now, since equation of tangent to a circle is here, equation of the tangent to circle x square plus y square equals to 2 is y equals mx plus minus under root 2 under root 1 plus m square. This is the first equation, and the second equation is equation of tangent to this parabola y square equals 8x is y equals mx plus 2 upon m. Okay, so we can get this as y equals mx plus a upon m in case of a parabola, and in case of circle it is y equals mx plus minus r under root 1 plus m square. Okay, so well, now since the tangents are common, so therefore we are going to equate these terms. Now if we equate, then these two terms, this term here and this term here, should be equal. So then therefore plus minus root 2 here. Now let's take the plus sign from here. Let's take the plus sign. So therefore this is going to be plus this is going to be plus root 2 into 1 plus m square under root equals 2 upon m. So if we square both sides, then it becomes 2 into 1 plus m square equals 4 upon m square. Now if we simplify it, then it becomes m square into 1 plus m square equals to 2, which gives us m raised to the power 4 plus m square minus 2 equals 0. So therefore m square plus 2 into m square minus 1 equals 0. Now this condition, this particular expression m square plus 2 cannot be 0 because m square is always greater than 0. So therefore this gives us m equals plus minus 1. Okay, so from here m is equal to plus minus 1. So the two equations, now substitute m equals plus minus 1 in y equals mx plus 2 upon m. We get the two equation of tangents, the two tangents. First tangent is y equals x plus 2, the second tangent is y equals minus x minus 2. Okay, now to get the points on circle, let's substitute y equals x plus 2 in the expression of circle, in equation of circles. Now equation of circle is x square plus y square equals to 2. So this gives us, so here this gives us x square plus 2 square equals to 2, which gets simplified to x square plus 4x plus 4 equals to 2, or x square plus 2x plus 1 equals 0. This is how this expression gets simplified to, which gives us x plus 1 square equals 0, or x equals to minus 1. So this is the value for x here. So the point should be the point, and now these 2 points should be equal. Okay, the x coordinate of these 2 points must be equal. Okay, so the first point is here, the first point is minus 1. Here this is also minus 1. Now since x equals minus 1, if you put here x equals minus 1, then y square equals 2 minus 1, or y square equals to 1, which gives us y equals plus minus 1. So this point is plus 1, and this point is minus 1. Okay, so the points P and Q, we have got it. Now similarly, if we substitute the equation here, the equation of tangents in the equation of parabola, we'll get, now in parabola y square equals 8x. We get, if we substitute the expression for y, we get, or let's substitute the expression for x, which is y minus 2 in first case, so which gives us y square equals 8y minus 16, or y square minus 8y plus 16 equals to 0, which gives us y minus 4 square equals to 0, or y equals to 4. Okay, now similarly from y equals minus x minus 2, we get y coordinate in parabola y2. This is y1, this is y2, as we get this y2 as minus 4. So the two coordinates for R and SR, this is 2, 4, and this is 2, minus 4. If you substitute the value of y here in the equation of parabola, you will get the value of x. Okay, so 16 equals 8x, which gives us x equals to 2. Okay, so now you have got all the 4 coordinates. Now you can easily get the value of the area. Since this is minus 1 and plus 1, so this should be plus, the y coordinate should be plus 1, and the x coordinate is 2, so this is 2, 1, and similarly this is 2 and minus 1. So now this unit is very clearly, this unit is 3 units, this is 3 units, which is equal to 2 plus 1, 2 minus minus 1, which is equal to 3, and this is equal to 2 units. I think So this is here. So now here this is 1 unit actually. Okay, this is 1 unit here. Okay, now so therefore area is going to be, so therefore the area is going to be, therefore area is, therefore here area is equals 2 into, since this is 1 unit here, this is 1 unit, so the area is since the lower region is this lower region is just the mirror image of the upper region in case of PQRS. So therefore we are going to just calculate the area of the upper region of this region, and then we are going to simply multiply it by 2 in order to get the area of the total of the full quadrilateral. So the area is going to be 2 into 3 into 1, that is the area of the rectangle, plus half into 3 into 3, which is equal to 6 plus 9 or 15 square units. Okay, so this is going to be, since base is 3 units and the height is also 3 units, that is 4 minus 1. Okay, I've drawn it smaller, but this is 3 units. So therefore half into base into height, which gives us the area of the triangle. So the correct answer here is option D. Okay, now so let's see another question. Question says for x belonging to 0 to pi, the equation sin x plus 2 sin 2x minus sin 3x equals 3 has infinitely many solutions, 3 solutions, 1 solution, no solution. Okay, so we are given with the expression as sin x plus 2 sin 2x minus sin 3x equals 3. Okay, so if we simplify this expression, this becomes 2 cos 2x into minus sin x plus 4 sin x cos x equals 3. This we can get by using simple trigonometric formulas or identities. So therefore we can write it as 2 into sin x into 2 cos x minus cos 2x equals 3. So this is nothing but 2 into sin x into 2 cos x minus 2 into cos x square minus 1 equals 3. Okay, so this gets simplified as 2 into sin x into 1 plus 2 cos x minus 2 cos x square equals 3, which is 2 into sin x into 3 by 2 minus 2 into cos x minus 1 upon 2 square. So this whole expression is the square of this term. So therefore this is equal to 3. Okay, now this is possible only when, this is possible only when first is sin x equals to 1, which is first case. Second case, and cos x minus 1 upon 2 square equals 0. This is the second case. And the third case is and cos x equals 1 upon 2. Okay, so these three are the cases here, but since here pi by since here from first, that is first, and from second, this is second. Okay, so from here if we simplify it, then cos x becomes pi by 2. So this is possible when, only when sin x equals 1 and cos x equals 1 by 2. These two expressions are simultaneously satisfied. Okay, not possible. Well, this condition, in fact these conditions are not possible to be satisfied simultaneously. Okay, so the correct answer is, this gives us no solution. Okay, so the correct answer here in this case is option D, which is no solution. Okay, so let's see other question. In a triangle, the sum of two sides is x and the product of the same two sides is y. If x square minus c square equals y, where c is the third side of the triangle, then the ratio of the in radius to the circumradius of the triangle is. Okay, so here in this case, the two sides which are, suppose A and B, let the two sides are A and B. Okay, so therefore A plus B equals x, which is given, and AB equals y, and x square minus c square equals y. So therefore if you substitute it, it simply gets A plus B square minus c square equals AB, or this implies as A square plus B square minus c square equals minus AB. Okay, after expanding this, so this becomes A square plus B square minus c square upon 2AB equals minus 1 upon 2. Okay, now since we know that cos C, which is the angle opposite to the side C, cos C equals A square plus B square minus C square upon 2AB. So therefore cos C here in this case is minus 1 upon 2. Okay, this gives us angle C as 120 degree, which is the angle opposite to the side C. Now 2r here 2r, that is the circumradius. Therefore circumradius, that is 2r, or here writing 2 into circumradius, which is 2r, equals c upon sine C. We know the angle C, that's why we are using c upon sine C. Actually 2r equals A upon sine A equals B upon sine B equals C upon sine C. Okay, so therefore 2r equals C upon sine C, which is 2c upon root 3, because sine 120 degrees is root 3 by 2. Okay, so this gives us r as C upon root 3. This is the first result that we have got, and we are going to use it further. Now in radius here in this case is, in radius, that is r, is s minus c into tan C upon 2. Well, here s is A plus B plus C upon 2, that is the half of the perimeter of this triangle, and in radius we know that equals sine A, in radius is equals to s minus A into tan A upon 2 equals s minus B into tan B upon 2 equals s minus C into tan C upon 2. Now since we know angle C, therefore we are going to use here this expression, s minus C into tan C by 2. So from here this gives us r as x plus, since A plus B equals x, so x plus C upon 2 minus C into root 3. So this gives us r as x minus C upon 2 into root 3. So from here, therefore, small r upon capital R becomes x minus C into root 3 upon 2c, which is into root 3 in fact. Okay, into root 3. So this becomes 3 into x minus c upon 2c. We simplify it, this becomes 3 into x minus c into x plus c upon 2c into x plus c. We have just multiplied and divided the expression by x plus c. So this comes out to be small r upon capital R as 3 upon 2 into x square minus c square upon c into x plus c, which is nothing but 3y upon 2c into x plus c. Okay, so the correct answer here in this case is 3y upon 2c into x plus c. So the correct option matching our answer is option B. Okay, so let's see another question. 6 cards and 6 envelopes are numbered 1, 2, 3, 4, 5, 6, and cards are to be placed in envelopes so that each envelope contains exactly one card and no card is placed in the envelope bearing the same number, and moreover the card numbered 1 is always placed in envelope number 2. Then the number of ways it can be done is, well, this is very simple problem, just a case of de-arrangement. Okay, this is nothing but de-arrangement, and we know that the expression for de-arrangement is, this is but de-arrangement, and this is equal to, then if p is the number of ways, then this is equal to, or let's write it by capital N. Okay, then capital N is equal to factorial N upon 1 minus 1 upon 1 factorial plus 1 upon 2 factorial. This goes on as 1 upon n factorial upon the condition that is n minus m. Here in this case m is 1. Okay, so here in this case n, that is number of ways, is going to be factorial 6 into 1 minus 1 upon factorial 1 plus 1 upon factorial 2 plus, or here, minus 1 upon factorial 3 plus 1 upon factorial 4 minus 1 upon factorial 5 plus 1 upon factorial 6 upon 5. So the correct answer is n equals, if we simplify it, we will get it as 265 upon 5, which is equal to 53. So the correct answer here in this case is option C, which is 53. Okay, so now let's see another question. Question says 3 boys and 2 girls stand in a queue. The probability that the number of boys ahead of every girl is at least one more than the number of girls ahead of her is. Now here they are asking that if they stand in the queue, then what is the probability that the number that, suppose if any girl is placed like this, if any girl is placed like this here, then what is the probability that the number of boys ahead of this girl is more than the number of girls ahead of this boy. So suppose if a girl is here, if this is G1 and if G2 is here, then these two places got to be occupied by boys. Since one girl is ahead of this girl already, this girl is ahead of this girl already, therefore the minimum number of boys should be 2 here. Okay, it is written at least one more than the number of girls ahead of her. Okay, so what is the probability that if they stand in a queue, then this becomes the case? So suppose, now let's suppose case 1, we make a girl stand here, G1, which we make here stand. Okay, now the total number of ways is factorial 5, we know that. So here in this case, suppose this is the case, if we make the girl 1 stand here, then and rest of the places be occupied randomly, and then we can interchange the girl. So the total number of ways are going to be, in this case, and n1 is going to be 2, because 2 girls are here, we are going to interchange them into total number of ways for these 4 positions, which is factorial 4. Okay, now the second case, which is case 2 that we need to consider, is here, this case has already been considered in this one. Now the second case that we need to consider here is if we put a girl here, because in this case if we put a girl here, then no girl, other girl must be behind her. No girl can be can be placed ahead of her, because if that is the case, if the second girl is here, then the number of boys in front of this girl must be greater than 1, that is at least the number of boys must be 2, but the place left is only 1. Therefore the other girl must stand behind her, behind this girl. Okay, these are the two cases. First case, the other girl must stand ahead of this girl, and in second case the other girl must stand behind this girl. Okay, so here in this case, one position, suppose random, this position is already fixed by the other girl. Okay, so the total number of ways and 2 is going to be, so the number of places which are left is 3, 1, 2 and 3, and since the total number of girls are 2, so we can interchange them, so it is 2 into factorial 3. So this is 12 and this is 48. So the probability here in this case is 48 plus 12 upon factorial 5, which is 60 upon 120 or 1 upon 2. So the correct answer here is option A, that is probability equals 1 upon 2. Okay. So let's see another question. The question says the quadratic equation px equals to 0 with real coefficients has purely imaginary roots. Then the equation px equals to 0 has only purely imaginary roots, all real roots, 2 real and 2 purely imaginary roots, neither real nor purely imaginary roots. Okay. So here in this case, since the quadratic equation px with real coefficients has purely imaginary roots, so therefore we can see that px is such that x square is minus a. This gives us px equals x square plus a. This is the case. Okay, and a is greater than 0. Since we can write here, if a is smaller than 0, then the roots will become real for px. Okay, so a is greater than 0. So this is the expression for px. Now if here we are asked that the roots for px, so writing px, this will be x plus a, x square plus a, in fact whole square plus a. So this is nothing but x raised to the power 4 plus 2a into x square plus a equals to 0. Here in this case a can belong to R. Okay, here in this case a can belong to R. Now so this gives us x squared. This is, we can say that this is a quadratic form in terms of x square. Okay, this is a quadratic form of x square. So we can write px. We can write px as x square whole square plus 2a x square plus a square plus a equals to 0. So therefore this gives us that x square equals minus 2a using the Rachare method plus minus under root 4a square minus 4a square minus 4a upon 2. Okay, so this gets simplified to x square equals minus a plus minus under root a iota. Okay, so this is the form, or x is plus minus under root a plus minus under root a iota. Okay, so therefore since x square is in the form of, r plus iota z. This is the real part, this is the imaginary part here. So therefore since x square is in the form of r plus iota z, therefore x is also in the form of r plus iota z, or we can write r1 plus iota z1. Okay, so Therefore x is in the form of r plus iota z. So now from here we can say that the roots for Px equals to 0 has neither real nor purely imaginary roots, or in other words the correct answer is option D. Okay. So now let's see another question. Now the next type of question is comprehension type question. The question says, let A, R, S, T be non-zero real numbers. Let P, AT square to AT, Q, R, AR square to AR, and S. Let P, AT square to AT, Q, R, AR square to AR, and S, AS square to AS be distinct points on the parabola y square equals 4ax. Suppose that PQ is the focal chord and lines, QR and PK are parallel, where K is the point 2a0. The question says the value of R is. Okay, so let's see what the comprehension really mean, what this paragraph really mean. So if we draw the diagram here according to the given conditions in paragraph, the parabola looks something like this. Okay, and this point here is K. This point is K, which is 2a0. And here, suppose the focus of this parabola lies, which is a0. Now, this point here is P, point P, which is given to be AT square to AT. Okay, and it passes from focus and meets parabola here, which is the point PQ is focal chord, so which is the point Q, and since it is a focal chord, its coordinates is going to be a upon t square minus 2a upon t. We'll come to it. Okay, so we are going to come to it after some time. And suppose this line is drawn here, or if we join P and K, the P and K will be here. So since another parallel line from Q starts parallel to the PK and it joins the parabola somewhat here at this point. This point is point R, which is AR square and 2AR. Okay, these two lines are parallel. Now this point at somewhat here, at this point is S. Let's draw a normal to S. Suppose this point is S. So if we draw a normal to S, which will look something like this actually. Okay, and S, which is, this is S, this is AS square to AS. Okay, so now let's see the value of R. Let's go to the first question here, the question number 51. Let coordinates of Q be, if we let coordinates of Q be a t2 square to a t2. Okay, now since PQ is parallel, is a focal chord, since it is a focal chord, so therefore T into T2 equals minus 1. So in case of, since this is the parametric equation given, and the parametric equations are represented in terms of T1, S, R, if the coordinate is AT square to AT, then it is represented as the a parametric coordinate T. So if the two coordinates T1 and T2 are there, then in case of focal chord, the two coordinates, that is T1 into T2, is minus 1. Okay, so here this is minus 1. So this gives us T2. This gives us T2 equals minus 1 upon T. So therefore, coordinates of Q is is a upon t square minus 2a upon t. Okay, this is what we have written here, a upon t square minus 2a upon t, right? Okay, so now slope of the line PK is, slope of line PK is simply, since the line PK is this, PK, we know the coordinates of these two points P and K, so we can easily write the slope as, slope of PK is 2at minus 0 upon at square minus 2a, which simplifies to 2t upon t square minus 2, right? And the slope of RQ equals, let's see which line is RQ. RQ is this line. We know the coordinates of these two, of R and Q, and we knew the coordinates of P and K, so we know the slope, and since these are parallel, therefore their slopes must be equal. So the slope of RQ is 2AR minus 2A upon T upon AR square minus A upon T square. So this gets simplified to 2 into R plus 1 upon T upon R square minus 1 upon T square. Okay, now since PK and RQ are parallel, now therefore slope of PK equals slope of RQ, because they are parallel. Okay, so therefore we can write 2t upon t square minus 2 equals 2 into r plus 1 upon t upon r square minus 1 upon t square, which gets simplified to 2 upon r minus 1 upon t. Okay, if we write it if we split this particular expression, then this becomes r plus 1 upon t into r minus 1 upon t. So these two terms are equal. So this gives us, so from here, so therefore r minus 1 upon t equals t square minus 2 upon t. So from here the value of r is t square minus 1 upon t. Okay, so the correct option here in this case is correct option is t square minus 1 upon t, the option D. Now the second part says, that is the next question, it says if st equals 1, then the tangent at P and normal at S to the parabola meet at a point whose ordinate is, ordinate means the y coordinate. Okay, so let's solve the other question, which is question number 52. It says that if st equals 1, which gives us s equals 1 upon t. Okay, so we can also write the coordinates of s as, therefore coordinates of s is from here a upon t square to a upon t. Okay, now the equation of tangent at P in case of parametric coordinates, equation of tangent at P is y equals 1 upon t into x plus a t square. Okay, so this is the equation of tangent at P in case of parametric coordinates. Right, now the slope of normal at S is minus S. Simple. Slope of normal at S is minus S, because the coordinates are as square and 2as. So in case of parametric coordinates, the slope of normal is minus S. And since s equals 1 upon t, therefore this is minus 1 upon t. Now, therefore, equation of normal is y minus 2a upon t equals minus 1 upon t x minus a upon t square. Okay, this is the equation of normal at s. Okay, so this gets simplified to minus ty plus 2a equals x minus a upon t square, or x equals minus ty plus 2a plus a upon t square. Okay, so from 1 and 2, therefore, see if it is the 2, the second equation, and this is the 1. Therefore, from 1 and 2, we can write that y into t minus at square equals minus ty plus 2a plus a upon t square. So from here, 2ty equals at square plus a upon t square plus 2a. Since here in this case they are actually asking us that if then the tangent and p and the normal at s to the parabola meet at a point. These two, if this is the tangent at p, then they meet at a point. Okay, so therefore there for that particular point the both of the equations are simultaneously satisfied. Therefore, substituting the value of x from the value of x taken from 1 and 2, we have arrived at this expression, and finally after solving this, it takes the shape as, it further gets solved as 2ty equals a into t plus 1 upon t of whole square. So from here we can say that y equals a into t plus 1 upon t of whole square upon 2t. Okay, so we can write y equals a into t square plus 1 of whole square upon 2t cubed. So this is the ordinate of that particular point. So the correct option here in this case is option B. Okay. So let's see another paragraph. Paragraph says, given that for each a belonging to 0, 1 not included, limit h tending to 0 positive integration from h to 1 minus h t raised to the power minus a into 1 minus t raised to the power a minus 1 dt exists. Let this limit be GA. In addition, it is given that the function GA is differentiable on 0, 1. The value of G 1 by 2 is, they are asking us the value of G 1 by 2. So let's see what is the question number 53 actually. Now GA here is limit h tending to 0 positive integration from h to 1 minus h t raised to the power minus a into 1 minus t raised to the power a minus 1 dt. Now therefore G 1 upon 2 equals limit h tending to 0 positive integration from h to 1 minus h t raised to the power minus 1 upon 2 1 minus t raised to the power minus 1 upon 2 dt. So which gets simplified as limit h tending to 0 positive integration from h to 1 minus h 1 upon under root t into 1 minus t dt. Okay, we can further write it as limit h tending to 0 positive sine inverse this, if we integrate it, then this is sine inverse t minus 1 upon 2 upon 1 upon 2 from h to 1 minus h. Okay, so now this is simply limit, or g1 upon 2 is simply limit h tending to 0 positive sine inverse 2 into 1 minus h minus 1 2 into 1 minus h minus 1 here minus sine inverse 2h minus 1. Okay, so if we write it further, this becomes g half equals, this is sine inverse 1 here, this is sine inverse 2 minus 2h minus 1, this is sine inverse 1 minus sine inverse minus 1. Okay, which is nothing but g half equals sine inverse 1 is pi by 2, this is minus pi by 2, so this becomes plus pi by 2, which is pi. So the correct option in question number 53 is option A. Now another question, the question number 54, it says the value of g dash 1 by 2 is, the value of g dash 1 by 2 is. Okay, now since GA is, this is question number 54, now GA equals limit h tending to 0 positive integration from h to 1 minus h t raised to the power minus a into 1 minus t raised to the power a minus 1 dt. This is GA. So g dash a becomes, if we write g dash a, it becomes limit h tending to 0 positive integration from h to 1 minus h. This becomes t raised to the power minus a into 1 minus t raised to the power a minus 1 ln, this is ln 1 minus t upon t dt. Okay, so therefore g dash 1 upon 2 equals limit h tending to 0 positive integration from h to 1 minus h t raised to the power minus 1 upon 2 into 1 minus t raised to the power minus 1 upon 2 ln 1 minus t upon t dt. Okay, which becomes 0 actually. Okay, so this becomes 0 because of this expression. Okay, so now therefore here the correct option is option D. Okay, so let's see another question or another comprehension. It says box 1 contains 3 cards bearing numbers 1, 2, 3. Box 2 contains 5 cards bearing numbers 1, 2, 3, 4, 5. Box 3 contains 7 cards bearing numbers 1, 2, 3, 4, 5, 6, 7. A card is drawn from each of the boxes. Let xi be the number on the card drawn from the ith box. I equals 1, 2, 3. The probability that x1 plus x2 plus x3 is odd is. Okay, so the probability that this will be odd will be in two situations. Or case 1, either 1 is odd, 1 odd, and 2 numbers are even. Out of x1, x2 and x3, 1 number is odd and 2 numbers are even. So this is the first case. So if this is box B1, this is 1, this is 2, this is 3 in case of B1. For B2 it is 1, 2, 3, 4, 5. And for B3 it is 1, 2, 3, 4, 5, 6 and 7. Right, in case 1 odd and 2 even. So this is question number 55 actually. Okay, so case 1, 1 odd and 2 even. One number is odd and two numbers are even in order to be the full this to be odd. So this can be taken place in the following conditions: 1 odd and 2 even. Either 1 is odd from here, or 1 is odd from here, or 1 is odd from here, and the rest two numbers from the other two boxes are even. So this can be taken place in the following ways. Suppose in first case the odd number is from box 1, then the total number is are 2, that because two numbers are odd in box 1, into 2. The rest of the numbers from box 2 and box 3 are even. So the two numbers from box 2 are even, and three numbers from box 3 are even. So therefore 2 into 2 into 3. Plus the odd number is from box 2, that is x2 is odd. So in that case only one number is even in box 1, into three numbers are odd in box 2, into three numbers are even in box 3. Plus one number is even in box 1, into two numbers are even in box 2, into four numbers are odd in box 3. Okay, the third case is the odd number is from x3. So this is equal to 12 plus 8, this is equal to 12 plus 9 plus 8, which is 29. Okay, now case 2 is all the three numbers are odd. Three odds, all the three numbers are odd. So in that case only one possibility is there. Two numbers are odd in box 1, three numbers are odd in box 2, and four numbers are odd in box 3, which is 24 total. Okay, so therefore total cases is total cases satisfying the condition equals 29 plus 24, which is here 53. Okay, now total number of cases is three numbers are in box 1 into 5 into 7. 5 numbers are in box 2 and 7 numbers are in box 3. So this is 105. So therefore probability is 53 upon 105. Okay, so the correct answer here is 53 upon 105, that is option B. Right, now other question, which is question number 56, it says the probability that x1, x2, x3 are in arithmetic progression is. Okay, so in case of 56, since these two should be in arithmetic progression, therefore 2x2 equals x1 plus x3. So therefore x1 and x3 must be even number. So therefore from here, since 2x2 equals x1 plus x3, so therefore x1 and x3 must be actually x1 plus x3. This is x1 plus x3 must be even. Okay, now this can take place in two conditions, right? First is both x1 and x3 are odd, or in second condition both x1 and x3 are even. So first case 1 is both x1 and x3 are odd. Okay, so in this case x1 belongs to 1, 3 and x3 belongs to 1, 3, 5, 7. Right, now also x1 plus x3 it belongs to 2, 4, 6, 8, 10. So therefore the total number of ways are, therefore total cases are 2 into 4, 2 into 4, which is 8. Okay, now in another case, in another situation, that is case 2, x1 and x3 are even. I mean both are even. Okay, so therefore x2 is nothing but 2 and x3 is 2, 4, 6. Right? So therefore in this case only total cases here is 1 into 3, which is 3. So total number of 11 cases are here. Total, this is x1 actually. This is x1, x1 is 2. Right? So the total number of cases are 8 plus 3, which is 11. So therefore required probability is equals 11 upon 105. Okay, so the correct option here is option C. Okay, so let's see another question. The next type of questions are matching list type question. Okay, so the question says, the first question says among them, let zk equals cos 2k pi by 10 plus iota sine 2k pi by 10, and k is from 1 to 9. List 1. For each zk there exists a zj such that zk dot zj, there exists a k belonging to 1 to 9 such that z1 dot z equals zk has no solution z in the set of complex numbers. R is this expression, this is equals to, and S is this is equals to. So from here we can easily estimate that P and Q belongs to 1 or 2, and R and S belongs to 3 and 4. So let's see here. P is, so first let's solve for P. Zk dot Zj equals 1. Okay, it is given, that's Zk dot Zj. Well, here this question is incomplete. This is equal to 1. It is given, and such that Z1 dot Z, here Z1 has no solution Z in the set of complex. Okay, so here this is Zk dot Zj equals to 1. Okay, so now Zk dot Zj equals 1. So this implies that e raised to the power iota 2 pi upon 10 into k plus j equals 1. Well, since zk equals cos theta k plus iota sine theta k, we can write it in the form of e raised to the power iota theta k, in fact. Okay, so since we know that, we can write it in this expression. So therefore moving forward, we can write that e raised to the power iota 2 pi by 10 k plus j equals 1. So which gives us cos 2 pi k plus j upon 10 equals 1. Okay, and sine 2 pi upon 10 into k plus j equals 0, because since this is only the real part, since we are given that zk dot zj equals 1, and this is only the real part of the complex number, and we know that real part of the complex number is this, therefore this part should be 0 and this part must be 1. So therefore we can say that, hence we can say that k plus j equals 10n and k plus j equals 5m. So therefore there exists a zj for each zk. Therefore there exists a zk for each zj such that zk dot zj equals 1. So this is true. Here in this case this is true, right? So p corresponds to 1, or this corresponds to p. You can write it more appropriately there. Okay, so now solving for q here. For q here, z equals zk upon z1, right? Here we can write that since z1 dot z equals zk, so we can write here z equals zk upon z1. Okay, so this equals e raised to the power iota 2 pi by 10 into k minus 1. Okay, so therefore if k belongs to 1, 2 to 9, z has a solution. Okay, so therefore this condition is false. Therefore q corresponds to false. It has a solution, and it is written in the question that it has no solution. Therefore this corresponds to false, and hence p corresponds to 1 and q corresponds to 2. So let's go for r here. In case of r, z raised to the power 10 minus 1 equals 0. Okay, since z raised to the power 10 minus 1 equals 0, so this implies us that z minus z1, z minus z2, well, this is a property of this complex number, that z raised to the power 10 minus 1 equals to 0 in this case when theta equals to pi, when theta equals to k pi by 10. Okay, so z minus z1 into z minus z2 and so on into z minus z9 equals 1 plus z square plus and so on to plus z raised to the power 9. So this gives us z raised to the power 10 equals 1. So this is the z raised to the power 10. So therefore, magnitude of 1 minus z1 into 1 minus z2 and so on to 1 minus z9 equals magnitude of this 1 plus magnitude of z plus magnitude of z square. So this comes out to be 10. So therefore from here, so therefore hence we can say that 1 minus z1, 1 minus z2 and so on to 1 minus z9 upon 10 equals 1. Okay, so therefore from here 1 corresponds to r. So now we can easily say after inspection that the correct answer is option C, but let's now prove that S corresponds to 4. So in case of S, here 1 minus cos 2 pi by 10 plus cos 4 pi by 10 and so on plus cos 18 pi by 10 equals 1 minus cos 4 pi by 10 plus 8 into 2 pi by 10 upon 2 equals 2. This will become minus 1. Okay, this will be only pi. Okay, this will be cos pi. So we can write here 1 minus cos pi. So this becomes 2. Okay. So S corresponds to 4 here. So the correct option here in this case is, this corresponds to 4. So the correct option here is option C. Now let's see another question. The question says, P is the number of polynomials fx with non-negative integer coefficients of degree smaller than or equal to 2 satisfying f0 equals 0 and integration from 0 to 1 fx dx equals to 1 is. So let's solve for P here. Let fx equals a naught x square plus a1 x plus a2. Okay, and a naught, a1 and a2 is greater than 0. Now since greater than or equal to 0 actually. Now since f0 equals 0, this gives us a2 equals 0, right? So therefore fx equals a naught x square plus a1 x. Now since integration from 0 to 1 fx dx equals to 1, so this implies that a naught x cube upon 3 plus a1 x square upon 2 from 0 to 1, this equals 1. So this gives us a naught upon 3 plus a1 upon 2 equals 1. Okay, and or 2 a naught plus 3 a1 equals 6, and hence therefore for integral solution, so for either a0 equals 3 or a1 equals 0 or a0 equals 0 and a1 equals 2. Okay, that is fx will either be 3x square or fx equals 2x. So the correct answers are, there are two solutions. Okay, so there are a total of two polynomials here, two polynomials, right? So therefore in this case this 2 corresponds to P. Okay, so let's see the option Q. The option Q says the number of points in the interval minus root 13 to root 13 at which fx equals sine x square plus cos x square attains its maximum value is. Okay, so the maximum value, we know that if fx equals sine, or if f theta equals sine theta plus cos theta, we know that maximum value of f theta equals root 2 or equals root 2 at theta equals pi by 4. Now therefore given fx, max is root 2 and at x square equals pi by 4, and within the interval, if we go by the interval, then there are two values of x square. First is pi by 4 and second is 9 pi by 4. So this gives us that x equals plus minus under root pi by 4 and plus minus under root 9 pi by 4. So therefore number of points equals 4. Two points are here and 2 points are from here. So the number of points are 4, and hence Q corresponds to 3. Okay, so the next is R integration from -2 to 2 3x square upon 1 plus e raised to the power x dx equals. Okay, so let's see how we go about R. Here, suppose I equals integration from -2 to 2 3x square upon 1 plus e raised to the power x dx. Now again, therefore, now if we just simplify, if we just multiply and divide it by e raised to the power minus x, then we get I as integration from -2 to 2 e raised to the power minus x 3x square upon 1 plus e raised to the power minus x. Okay, so now if we add both of them, therefore if we add both of them, we get 2I equals integration from -2 to 2 3x square dx, which is just x cubed from -2 to 2. Okay, therefore 2I equals 8 plus 8, which is 16. This gives us I equals 8. Okay, so the value of R is 8, which is therefore 1 corresponds to R here. Now S, let's see what S says. S says that this expression integration from -half to half cos 2x log 1 plus x upon 1 minus x dx upon integration from 0 to 1 upon 2 cos 2x log 1 plus x upon 1 minus x dx equals, what does it correspond to? Here S, now as cos 2x dot log 1 plus x upon 1 minus x is an odd function. Okay, this is because f minus x in this case is cos 2x. We know that cos minus x equals cos x, so we can write here cos 2x simply into log 1 minus x upon 1 plus x, which is the negative of, if we change the numerators and denominators here, if we interchange them, then in case of log it becomes the negative, so it will be cos 2x log 1 plus x upon 1 minus x. Okay, so therefore this is an odd function, and hence, since the limit is symmetrical about 0, so therefore this integration from -half to half cos 2x log 1 plus x upon 1 minus x dx equals 0. So the correct answer for S is 0, and hence 4 corresponds to S. So in this case the correct option is 2, 3, 1 and 4. So the correct option here is option D. Okay, so let's see another question. Question says, let yx equals cos 3 cos inverse x, x belonging to -1 to 1 included, x is not equal to plus minus root 3 by 2. Then 1 upon yx into x square minus 1 d2 yx by dx square plus x dy by dx plus x dy by dx equals. Now for p, here if we go about p, then since y equals cos yx equals cos 3 cos inverse x, so therefore from now onwards we are going to write yx as y simply. So dy by dx, if we differentiate it, this becomes minus sine 3 cos inverse x, and using chain rule it becomes into minus 3 upon under root 1 minus x square. Okay, so we can write it as under root 1 minus x square dy by dx equals 3 sine 3 cos inverse x. Okay, we can write it like this. Now if we square it, if we square the above expression, we get 1 minus x square dy by dx whole square equals 9 into sine this expression. Okay, we are going to get this. We can simplify it like 9 into 1 minus cos square 3 cos inverse x. Okay, which is nothing but 9 into 1 minus y square. So from here we can say that 1 minus x square into dy by dx of whole square equals 9 into 1 minus y square. Now if we differentiate it again, we get 2 into 1 minus x square dy by dx into d2y by dx square plus dy by dx of whole square into minus 2x equals 18y into dy by dx, which will be compensated by negative sign. Okay, so from here if we divide the whole expression by 2, we are going to get and multiply the whole expression by minus and divide it by 2, we are going to get x square minus 1 into d2y by dx square plus x into dy by dx equals 9y. Okay, so the correct option here, now if we are going to multiply, if we are going to divide the whole expression by y, so from here 1 upon y into x square minus 1 d2y by dx square plus x into dy by dx equals 9. So the correct option is 4 corresponds to P. Okay, now 4 corresponds to P. Now Q is asking us, let A1, A2 to AN be the vertices of a regular polygon of n sides with its center at the origin. Let AK be the position vector of the point AK. K equals 1 to n if summation of this expression equals summation of this, that is cross product is equal to the summation of cross product is equal to the summation of dot product, and the minimum value of n is, suppose here the sides are like this. Okay, it goes like this. Now here is the center, so this angle is going to be 2 pi by n. This is A1, this is A2, this is A3 and so on. This is AN. So the angle between the two position vectors is 2 pi by n. Right? And now the magnitude is magnitude of the position vector here, since it is given that center is at origin. Suppose if the center is at origin, here the center is at origin. So if we say that the magnitude is r, then summation, or if we write that a k cross a k plus 1, it is summation of a k plus 1 sine 2 pi by n. Okay, and a k dot a k plus 1 is going to be summation of a k plus 1 into cos 2 pi by n. Okay, so therefore integral we can write it in the form as, therefore integration from k equals to 1 to n minus 1 a k cross a k plus 1 is equal to n minus 1 into r square. Since both of the values are r, n minus 1 into r square into sine 2 pi upon n. Okay, and integration from k equals 1 to n minus 1 ak dot ak plus 1, we can write it as n minus 1 into r square into cos 2 pi upon n. Okay, so therefore since both of them are equal, therefore we can write that tan 2 pi upon n equals to 1. Okay, since both of the terms are equal, so from here 2 pi by n equals pi upon 4, which gives us n equals 8. N is equal to 8 here. So therefore 3 corresponds to Q. Now R is asking us that if the normal form of point P H1 on the ellipse x square upon 6 plus y square upon 3 equals 1 is perpendicular to the line x plus y equals 8, then the value of H is. Now in case of ellipse, in the case of given ellipse, this is R. Now in case of ellipse, equation of normal is ax upon cos theta minus by upon, here actually yes, ax upon cos theta minus by upon sin theta equals a square minus b square. So from here we can write that the equation, therefore equation of normal is root 6 x upon cos theta minus root 3y upon sin theta equals 3. And now its slope is 1. Since it is given that the normal of the point this on the ellipse is perpendicular to the line, now its slope is minus 1. We know that if suppose the slope of this normal is s, then s into minus 1 equals minus 1. So from here s equals 1. So therefore slope is going to be 1. So now since slope equals 1, so this gives us that tan theta, if you write it in particular form, this gives us tan theta equals 1 upon root 2. Right? So tan theta is 1 upon root 2. Now as it passes through h1, we can write root 6 h upon, since tan theta is 1 upon root 2, so cos theta, therefore cos theta is equal to root 2 upon under root 2 plus 1, which is equal to root 2 upon root 3. And sin theta is equal to, similarly sin theta will be 1 upon root 3. So therefore root 6h upon under root 2 upon 3 minus root 3 upon 1 upon root 3 is equal to 3. So if we simplify it, we get h equals 2. So the value of h is 2. Okay, so here 2 corresponds to r. Now the number of positive solutions satisfying the equation tan inverse 1 upon 2x plus 1 plus tan inverse 1 upon 4x plus 1 equals tan inverse 2 upon x square is. So in case of s, here if you write s, so in case of s, since it is given that tan inverse 1 upon 2x plus 1 plus tan inverse 1 upon 4x plus 1 equals tan inverse 2 upon x square. Now since we know that tan inverse x plus tan inverse y equals tan inverse, we know that tan inverse x plus y upon 1 minus xy. We know this identity. So therefore this will become tan inverse 1 upon 2x plus 1 plus 1 upon 4x plus 1 upon 1 minus 1 upon 2x plus 1 into 4x plus 1. Okay, so this is equal to tan inverse 2 upon x square. So from here, if we simplify it, we get 6x plus 2 upon 8x square plus 6x equals 2 upon x square, which on further simplification gives 3x plus 1 upon 4x plus 3 equals 2 upon x, where x is not equal to 0, right? So this gives us 3x square minus 7x plus 6 equals 0. So if we solve it, we will get x equals 3 or minus 2 upon 3. So here, since the positive solution is 3, this is negative, so this is discarded. So therefore here the number of solutions is 1. Therefore number of positive solutions equals 1. So the correct answer here in this case is 1 corresponds to S. So the correct option is 4, 3, 2, 1. So the correct option is option A. Okay. Now let's come to the last question of this question paper. Let f1 from R to R, f2 from 0 to infinity to R, f3 from R to R, f4 from R to 0 infinity be defined by f1 is this function, f2 is defined like this, f3 is defined like this, and f4 is this. So the conditions are here. Well, the question here is, I think it is incomplete, so let's complete the question first. f1 is f2o f1 f2o f1 is, and s is f2 is neither continuous nor 1, third is differentiable but not 1, and 4 is continuous and 1, 1. Okay, so here option A is P, Q, R, S, B, C, D. These are the 4 options. So option A is 3, 1, 4, 2. Option B is 1, 3, 4, 2. Or C is 3, 1, 2, 4. Or 1, 3, 2, 4. Okay, so let's see how to solve this question. Now f4 is, first is P is about f4. So let's see what f4 is. f4 is f2 f1x if x smaller than 0, and f2 f1x minus 1 if x is greater than or equal to 0. So in case of P, here f4x is nothing but f4x is x square, that is, or in more detail if we write, it is f2 magnitude of f1 is f2 f1 x is smaller than 0, and f2 f1 x minus 1 if x is greater than or equal to 0. So this becomes x squared if x is smaller than 0, and e raised to the power 2x minus 1 if x is greater than or equal to 0. Now easily if we plot it, the graph becomes something like this. For x smaller than 0, this is x squared, but for x greater than 0, it changes abruptly like this. Okay, so graph is like this. So if we draw this line parallel, so it is cutting the graph at 2 points, and hence it is not 1 1, but it is on 2, because f4 is from r to 0 infinity. So y smaller than 0 is not in range actually. Okay, so therefore this function is onto. Therefore f4x is onto but not 1 1, right? So here p corresponds to 1. Now let's see what is q here. Q is f3. Q is about f3. So f3 is, the function f3 is sin x if x is smaller than 0, and x if x is greater than or equal to 0. So if we draw q here, then q will look something like this. And here it will be like this. Very clearly it is not 1 1. It is not 1 1, and it is differentiable at this point. We know that the graph sin x for x smaller than 0 and x for x greater than or equal to 0, this graph is differentiable at this point. Okay, this is differentiable at x equals 0, and hence this is differentiable but not 1 1, but this is not 1 1. Okay, and hence differentiable but not 1 1, and hence this corresponds to q. 3 corresponds to q. Okay, so from here we can easily estimate that the correct option is one of B or D. So let's see what is R asking us. R is F2O F1 is. So from F2 and F1 we can say that here F2O F1 is nothing but x square when x is smaller than 0, and e raised to the power 2x when x is greater than or equal to 0. Okay, F2O F1, in this case this is nothing but F2 of F1, right? So if we put e raised to the power x instead of x here, so this becomes e raised to the power 2x for x greater than or equal to 0, and x square magnitude will vanish, x square for x smaller than 0. So therefore its graph will look something like this. The graph, suppose we are solving R here, the graph will look something like this. But here this will be discontinuous and it will start from here. Okay, so this is the solution of this, and hence R is neither continuous. This is also not 1 1. Okay, so therefore this is neither continuous nor 1 1. Okay, so 2 corresponds to R. Now for S, F2 is, if we draw simply F2 now, to see the domain of F2 is from 0 to infinity and the range is R. So in case of S, if we draw the diagram for F2, the graph for F2 is simply this, right? Okay, and therefore F2 is, it is continuous, since this is not in the domain. Okay, this part is not in domain, not in domain. Okay, so this is continuous and 1 1. This is continuous and 1 1, since any line parallel to x-axis intersect the graph only at one point. Okay, so this graph is continuous and 1 1. Therefore S here is 4. 4 corresponds to S. So the correct option here is 1, 3, 2 and 4. The correct option is option D. Okay, so that is the end of our discussion on the solutions of JEE Advanced 2014 mathematics paper.